Look at this amazing shape. It looks like a square surrounded by other squares. But the amazing part is that no matter how much I zoom into it, it turns out that I find the same pattern once again. Notice I'm zooming into a square. Again, I see squares around it. I zoom into this square. I see squares around it. And this continues. Something even more interesting happens in this Mandelbrot set. As I zoom into it, I go deeper and deeper. I find the same pattern emerging again. As I go further deeper into it, let's look for it. The same pattern will in fact appear once again. Fascinating and colorful as it might be, we will see the same pattern emerge, let's say, once again as we are seeing now. What we are looking at are called fractals. And this brings me to the next interesting activity in the YByte Python curriculum available at www.ybyte.in. This activity is called Fractals and Recursion. Now, this, in my opinion, is a very, very, very interesting activity and also deeply thought-provoking. Fractal is basically a geometric shape that repeats itself at multiple levels of magnification and appears similar at any scale, as we just saw. Let's take a few more examples. Let's say we had this triangle, and I divided this into 4 equal triangles. So, I get, let's say, 4 triangles. I applied the same rule to the smaller triangles. And I kept on doing this to all the triangles that were obtained. Of course, I will end up with a very elaborate pattern, but this will be self-similar because at every scale, basically I have triangles that have been divided into 4 smaller triangles. Another very popular example is this of Koch curve. Koch curve starts from a triangle, say an equilateral triangle. I take this triangle and convert this into star by, let's say, creating, an equilateral triangle from the inner 1/3. And I keep doing this to every side. So I obtain this and I keep going. I end up with what's called the Koch curve. Again, you can imagine that no matter how much you zoom in, you are going to see this pattern here. We already saw this for the Mandelbrot set. But you may be wondering, well, is this just some kind of figment of imagination, or are there any real applications? Well, it turns out that fractals are in fact in a lot of places around us. In nature, our own blood vessels are like fractals. Tree branches are like fractals. Coastlines of continents and islands are like fractals. In man-made stuff, fractals are used in architecture, in computer graphics, in art. I've seen people talking of using fractals in economics, in music, and so on. So basically, there are a lot of uses. But still, you may be wondering, well, why is it that we are interested in fractals? The reason is, using fractals, we can illustrate and understand an extremely interesting, though somewhat confusing programming concept called recursion. Remember, this activity is called fractals and recursion. Recursion is basically a function calling itself, which is very, very, very interesting, but like I said, can be a bit confusing. It's a little bit like, being in front of an infinity mirror. So basically, let's say I have 2 mirrors and, one in front of me, one behind me. You'll notice that I'll get an infinite set of images. So every mirror is giving you an image, and the next mirror is giving the image of the image, and so on and so forth. Recursion is a little bit like that. We will learn recursion through this activity in quite a fun way, because fundamentally fractals are fun to program, allow us to get very intricate patterns with very limited amount of code. And that's what makes us interested in fractals. In fact, it turns out that fractals and recursion go really, really well together, because recursion is an effective way to generate fractals, and on their part, fractals are an effective way to understand and visualize recursion. That's why I call this a win-win situation. Recursion can be a little confusing, but when we see it being, when we are able to visualize it as we build these fractals, I think the understanding becomes much better, and we will be able to apply this in many more situations. So what are we going to do in this project? Well, we will use recursion to build some interesting fractal patterns in Python Turtle. The 2 patterns we'll build are shown below. One is a square pattern. Notice every square gives rise to 2 squares on, let's say, left and right, and this continues. Likewise, the tree pattern. Now, first look, tree pattern will look very different from the square pattern, but there is a deep similarity, as we'll explore later. In the tree pattern, every branch gives rise to 2 other branches, and that's how the tree sort of grows. Now, apart from just drawing this, in fact, we will understand these codes in detail to sort of appreciate how these codes actually run. And that brings me to the learning goals from this activity. First and foremost, we are going to learn about recursion. What is recursion? What kind of problems can be solved with recursion? How does a recursive code evolve? Now, it turns out that a lot of work gets done in with recursion with a small ordinary looking function, but when we call it recursively. However, like I said, recursive codes can be a little bit difficult to understand. What we will do is to go slow and break down the process into smaller steps so that we can really visualize what's going on and understand every detail of it. Of course, through this process, we will get an appreciation and introduction to the beautiful and fascinating world of fractals, which is why I think this activity is really, really, really interesting. As always, we are going to do this in a step-by-step manner, and we'll start that from the next video. YBytes Python curriculum is completely unique because it's totally activity-based. We apply concepts to activities, and through that, we learn Python in a fun manner. Look at our website for more details and enjoy programming. Take care. Thank you so much. Bye-bye.